Hello, mate, and welcome back to Let's Code Season 6, Episode 24. Can you believe it? And we're still going. It's about time that we got the enemies able to attack us. We can already attack them as per the last episode, and we can pick up items and drop items. And we can even use items. But now it is time to start adding some danger. So without further ado, let's do this. But we've got to do some tweaking of some existing code as well. This is part of the process when you're developing a game. Perhaps you learn a new method of doing something, or in the case of this series, where I've kept a lot of the code as simple as possible to try and keep it as easy to understand, it's time to refactor some of that code to just make it a little bit less verbose, to make it a little bit more succinct. So we're going to be doing a bit of that as well. One such example of that refactoring is in our getAdjacent method within our room class. Now we've made some changes here because this is just a much more succinct way of doing it. And I also needed to make a couple of corrections. So what we do here is we obviously define our getAdjacent and we take in the position that we're actually wanting to check the adjacent cells of. And then we create an empty list called list of possible cells. And then what we do is we go through a list of positions 0, 1, 0, -1, 1, 0, and -1, 0, which are the directions above, below, to the left, and to the right of our existing cell, which is why new position is equal to our current position and the position of the cells, like you can see here. Then all we're doing is we're checking that the cells are within the bounds of the actual room that we're in. So we're saying that 0 must be less than or equal to our new position 1, which must be less than the size of the matrix in the Y direction. And then we're saying that 0 must be less than or equal to the position's X position, and which must be less than the size of the matrix in the X direction. If it meets those criteria, then we will simply add the position that we have, or the object that is in the position. We have a get method, which we'll talk about in a minute. And this simply adds it, all the contents of that cell, to our list. Then what we do, our very last line here, return I for I in list of possible cells if I is not 0. What we're doing is we're taking all of the empty cells out of that list, so that all we're returning when we call this method is a list of objects if there are any. Otherwise it'll just be an empty list. Now, in order to get everything working as we want to, we need to pass the player through as a parameter to our entity class, which means that we need to add the player as an argument for the update class in the room method, which is what you've done here, what I've done here, I should say. And you'll notice that in is subclass type thing underscore blah blah blah, the thing update now passes the player through as a parameter. This just means that when the enemy attacks us, it has a reference to the player object, so it knows what to damage, which means that we also need to pass this player parameter through from the game class, which you can see here. So this is the update method in the game class. And again, what we've done is where we've got self.currentroom.update, we've now passed in self.player as a parameter. This will pass the player through to the rooms update method, which is the one that we just looked at, which passes the player method or the player reference onto the entity class's update method, which we have here. And as you can see, the update method has got some new stuff in it. So let's talk through this. The first thing we're doing is we are now taking in the player as a parameter. I actually put game in here when I was testing something, so you don't need to put the global game line in your code. It will work just the same without it. And what we're doing now is we're saying if the player, which is the player that we've passed in as a reference, is in the self.room.getAdjacent, in other words, whatever is returned from the getAdjacent method when we pass in get object position self. So we're saying to the room class, wherever I am in this room, tell me what is in the adjacent cells. If the player is within those adjacent cells and our get priority is still attack, then we will say a message and we'll say blah 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 attacks the player, which is all that is just player.add message. And then where we've got the curly braces, we're replacing that with self.getName. And then we're taking damage, and all I'm doing at the moment is I'm just passing in the enemy mob's level as the amount of damage that we're going to deal. You can Google search for decent damaging algorithms that will help you figure out how much this number should be. Ideally, it wants to be in some way tied to the level of the enemy mob so that it makes sense. Obviously, if you've got a level 10 enemy mob, you want it to be doing more than a level 1. So yeah, there are a whole bunch of different algorithms that you can use, different formulas you can use to actually generate how much attack damage a mob puts out. It's a little bit outside the scope of this tutorial series, so I will leave you to do some looking into that on your own steam. So that's all we're doing, and then obviously we're saying else self move. So if we're not next to the player, or we are not in attack mode, then we will just move instead. So this is the take damage method that goes into the player class, and what we have here is we are taking in a number, which, if you remember from the previous method that we were looking at, is the level of the enemy that's attacking us in the case of this, but it will be whatever number you put in as the amount of damage that the enemy deals. The next line is what we call a ternary operator, and it is an if-then statement rolled into one line. So what we're saying is that the total damage is going to equal, and then we're saying 0 if number minus self dot get total defense is less than 0. In other words, if our defense is so high that it actually cancels out this number, we're just going to say total damage equals 0. The reason we do that is because if we say number minus self dot get total defense is a negative number and we subtract it from the hit points, we're actually going to be healing ourselves. So we don't want a situation where if an enemy attacks us, we get healed because our defense is so high that it actually makes damage a minus number. So we're going to clamp it to 0, basically. That's all we're doing. And then we're saying otherwise, if it's not less than 0, it's just going to be number minus get total defense. So if you remember, we had the get total defense method that we looked at in the previous video. So we're now utilizing that here. Then we're just saying that the number that they've sent across, we'll subtract that from get total defense, and then we'll take however much damage is left after that. And then we're just saying self-add hit points 0 minus total damage, because obviously we want our hit points to drop, not go up. So we're adding hit points, but we're actually adding a negative number, and then that will allow the enemy to attack us and do us damage. Now at the moment, because our player's got 100 hit points and this thing's only going to be hitting us for 1 minus whatever our get total defense is, chances are that you are going to have to tweak the numbers a little bit to get the enemies dealing as much damage as you think is appropriate. But again, as I said, you know, Google that, figure some numbers out for yourself. That's a little bit outside the scope of this tutorial series, but it's just a damage algorithm that you want, really. So this is the get method that I was talking about inside the room class, and all it does is it returns whatever is in the position that we're looking at. So this is just a shorthand way of doing, because we've done this function multiple times, but it makes more sense to have it as an actual method or function that we can just call rather than having to type the same code over and over again. So what we're doing is we're taking a position and we're checking that that position is within the bounds of our matrix. In other words, if position 1 is greater than or equal to the length of the matrix, or it's less than 0, blah blah blah, just the same check over it that we've done many times before. Then if it is outside the bounds of the matrix, then we're just going to return none. So that's what the return from this method will be if it's outside the bounds of the matrix. If it's inside the bounds of the matrix, then we're just going to return whatever is at position 1, position 0 of the get matrix property within the class. And that's just a shorthand way of doing that so that we can basically speed up how we do this in future. So I would encourage you, now that you're getting a better understanding of how these functions work, is if you can see something that you can make simpler within the room class or within the player class, by all means refactor your code and experiment. You can save this as one file and then create a backup file and just play and see what happens. I would highly encourage you to do that. Just keep a backup of when you get it working, keep a backup so that you always know you've got something that functions that you can go back to, because 90% of the fun in coding is figuring things out on your own and learning how to do things that perhaps aren't covered in the tutorial series that make your game different from the code that I'm putting up, because there's obviously 100 odd people that are making this code or working their way through it. So adding any unique quirks and tweaks to it that you think will help is obviously going to make yours stand out from other people's. Anyway, folks, that's all there is for this video. It's a nice short one again, just about 10 minutes. I hope you found it useful. Let me know what you think in the comments below, and I will see you in the next one. But until then, you know what to do. Take damn good care of yourselves, all right? Bye-bye.